Hi, we're going to look at what the ingredients are to come up with the so-called theory of everything. What in the world do we need to mix into this thing so that we could describe from a bottom-up point of view what in the world makes up the universe around us? So let's go back to our screen share here. Hold on one sec while I figure out what happened. Here it is. So we've got this picture here of a 26 real dimensional universe. And let's focus now on there's really 24 spatial dimensions and 2 time dimensions. So in the 24 spatial dimensions, of the 10 spatial dimensions that deal with matter, we have 4 of them here called space-time. And for dark matter, equivalently, we have 4 of these dual dimensions over here for dark matter. And then we have these compactified dimensions here that are the higher realms, if you will, of what's going on. Now, in the entire space that we're dealing with here, matter is really only in 10 dimensions. Dark matter is only in 10 dimensions. But we end up with these things called bosons. An example is a photon that carries electromagnetic energy, and that bounces around in all these dimensions here. It's not confined to just one or the other. It runs everywhere. One example of this that got the Nobel Prize in 2012 was the Higgs boson. The Higgs boson, again, it's a boson. It is everywhere, and it sounds hard to believe, but it scales the actual amount of energy associated with each of the different constituent elements that we're going to be dealing with here. So the Higgs boson is a key thing. So let's take a look at what's going on. I'm going to go back up here to the so-called standard model. This standard model has been around since 1975. And let's look at it and see what it says. We have things called leptons. An example of a lepton is an electron or an electron neutrino. And it has these other states here. These other states are actually resonances of the first state that we see over here. That is, the electron has 2 other possible resonances, one to a muon and one to a tau. The electron neutrino has a resonance to a muon neutrino and a tau neutrino. And that comes about because the compactified dimensions that we saw for the matter subspace, the 10 dimensions, the 6 compactified dimensions had 3 holes, and the 3 holes create that resonance that we see here. So we have really just one thing, the electron and the electron neutrino. And then we have these things called quarks. But as we observe, the quarks are themselves made up of subquarks, and so it goes. And the issue is there could very well be resonances occurring here for these other quarks that come about from the fact that there are 3 holes in the compactified dimensions. That is, there might only be one up and one down quark, and they each have the up quark has 2 resonances, and the down quark has 2 resonances. That's, again, as a conjecture. So we're going to need, and each of the up quarks and down quarks is made up of themselves 3 subquarks. So that's what we end up with here for the most fundamental thing is is two different types of subquarks and two different types of leptons. And finally, we get off here into the Higgs, into the boson area. And in the boson area, we have this photon here. And the photon by itself could very well generate these other states that we see here, the Z boson and the W boson. The gluon is something that attempts to capture gravity, which we're not going to talk about here. And here we saw the Higgs boson. So this is what we end up with for the piece parts. So what in the world is missing from this picture? Well, what's missing is we never talked about the arena that it's in. The arena that it's in is actually this 26-dimensional space. And the 26-dimensional space, again, 24 spatial dimensions and 2 for time. The 24-dimensional space that we're dealing with here itself, it has to be included in the model. So we have space compartments that are quantizations. They'd have to be included in this model somewhere. And these space compartments themselves are discrete. That is, the space is quantized into a foam, and we can have subquarks exist in the space compartments. But Ron Cowan observed that there's a exclusion principle that occurs. We can't have more than 2 subquarks in any one space compartment. That is, that we can have, say, for example, an up subquark and a down subquark in a compartment. When you try and put in one more, it'll get bounced out. He physically ended up observing this happening. So we have to include space as part of these parameters here. This then captures only part of what we're dealing with here, because that we've now covered the matter side of things. Okay, so now let's go one more here for dark matter. So for dark matter, what changes? Well, dark matter has no charge. It has subquarks, but there's no charge, no electron, no neutrinos. So we lose out on all of that here. And we just end up with these up and down dark matter subquarks. Now, the other thing that's missing from this whole picture, now that we've included space and the space compartments in part of the story, is the strings themselves. The strings that capture and resonate to give us, if we go back here to our picture in the standard model, we saw the electron was in fact encompassed by 10 strings. In fact, let's get out of this entirely and go all the way back to, can I do this? No, I guess not. Hold on. Here we go. When we go clear back to what we're dealing with here, what we see is dark matter is living over here, and then we have these strings that we talked about with the electron, and Ron Cowan was able to capture these strings resonate. They're bouncing all over the place. He was able to stop them. So it's more than just clairvoyance. He has the ability to manipulate, to psychokinetic, stop the motion of the electron, which is 10 strings that resonate. The energy inside it gives it the appearance of a particle called an electron, but in fact, it's really filled up with resonating energy. It's not really a particle and has a hole in the middle. It's a torus. And so we have to capture what the strings are, what makes up these strings. One thing that we've just kind of dropped off here is, what in the world are these neutrinos doing? Are the strings made up of neutrinos? What is going on here? So these are all the ingredients that we need to deal with in any theory here. The thing that Ron Cowan stressed repeatedly is if you go down into this microcosm and listen, the cacophony is incredible for the vibrations of the things like electrons and the subquarks that make up matter. And they're simply much more energized than they are for dark matter, which is much more quiescent, but it is still vibrating, but it's not vibrating at nearly the intensities that we see here for the for things like electrons that are literally screaming. So the music of the spheres is this incredible cacophony of all of these things going on here. And this does leave out the question of why wouldn't we observe purely energy forms here in these higher realms? And there probably are there, and they'll have to be included, and they're resonating in some way to gain a critical mass and achieve sentience. But all of this is to be included in some yet to be determined theory of everything. So with that, let's stop things, and we'll see where things go from here.